The broadcast is now starting. All attendees are in listen-only mode.
Good morning, everyone. We'll get started here in just a moment. If everyone can hear me, can you please raise your hand in the GoToWebinar interface just so I can make sure my audio is working here? Perfect. Thank you, guys. All right, we'll get started here in just a moment. There's still a bunch of people still logging in and connecting to the audio, it looks like. All right. Good morning, everybody. I know some of you guys are still connecting. If you're not able to see the screens yet, today's webinar session will be recorded and it will be posted to our YouTube channel. So if you guys are interested in watching today's recording after the fact, or you want to review some of the information, feel free to jump over there. If you don't have access to YouTube, you can always email me and I will shoot you back the recording directly. So with that, let's go ahead and get started. So today we're going to be talking about SOLIDWORKS MBD, so SOLIDWORKS model-based definition. So let's go ahead and jump in, and we'll start by talking a little bit about what SOLIDWORKS MBD is. All right, so that's the question of the day, right? What is SOLIDWORKS model-based definition? So the idea behind SOLIDWORKS definition, or the easiest way to explain, I guess, is let's use a scenario. Let's talk about the manufacturing process or the design process that we're going to go through to build this thing, okay? So when we're looking at this from the perspective of a SOLIDWORKS user, right, this is a fairly straightforward process to design and essentially get this thing built, right? So if we were to start on this process, with that being our final goal, typically we start in SOLIDWORKS and we'd actually build the model inside of SOLIDWORKS, right? And then when we want to manufacture this, what do? We take this information and we share it with those machinist guys and they build it for us, right? It's simple as that. We just build a 3D CAD model, send it over to them, and it gets built. They take a nice stock piece of material, we'll surface it, throw it on the lathe, cut it all out, drill some holes in it, and we're good and happy, right? Unfortunately, that's really not the way that it happens, right? So currently, or in most cases, what we'll do is we'll start with a 3D CAD model, and then we'll have to spend quite a bit of time and effort actually building this thing called a drawing. So in the drawing, we'll go through and we'll detail all the individual things that we need to talk about as far as dimensions, call-outs, different holes, and we'll need to spec all of this stuff out, including all of its the datums in it, the tolerance values, all the details that we want going on there. And then if our drawing is ambiguous enough, we'll have to have a couple of conversations with our machinists so that they understand exactly how we want to tackle this so that they can build it. So the idea behind MBD is to help alleviate this process a little bit, to take these complex or these drawings here and essentially start to generate the information inside the 3D CAD system. So using something like SOLIDWORKS. So let's talk about this in a little bit different perspective. So organizations, or one particular organization that has adopted this already is GE. So I'm not sure if everybody here is familiar with the GE Brilliant Factory, but essentially they have a couple key goals. Their goal was to increase production. So they had a certain percentage of yield through their battery factory or their Brilliant factory, and then they instituted this idea, this Brilliant Factory, this practice, where they started with an automation process, stepped through a prototyping aspect, use some system analytics, and then actually use model-based manufacturing to build everything. So this kind of novel approach to these 4 pillars to start to build towards a better future or a more robust solution for their process. And what you'll notice is that last thing, that model-based manufacturing. Essentially what their goal is in that manufacturing process is to eliminate the need of using 2D drawings to communicate the intent for the machinist, the manufacturer. So what we're using now is a 3D CAD model, and that 3D CAD model has all of the relevant information. We're getting the plane cuts that we need, the section views inside of it. We're getting all the relevant dimensions. And what we're doing is we're putting it into an environment that is very 3D focused. So we're not trying to interpret drawings any longer. We're no longer stuck trying to figure out, okay, what does this thing even mean? So funny little comic here, right? We put balloons on our drawings all the time. So what does that mean to the machinist or the assembler? In this case, they took it a little bit too literally, and they're putting balloons with A, B, C, D, and E, and actually attaching them to the building. So a little bit too literal, but you can see the complications that come with putting in information like this. It can be difficult to interpret exactly the surfaces that you're intending for this, or what your idea is. So our current process, right, we're spending a lot of time generating this 2D drawing. Now, what's interesting about these 2D drawings is they're all built off of these 3D CAD models. And these CAD models, no matter how complicated they get, whatever information we throw into them, depending on the user's ability to interpret it, it can mean one thing or another, right? So as we look at our drawing, we see 2 concentric holes. Well, does that mean that one is material and one is a hole? Or does that mean there's a second extrusion on it? It's a great question. So in essence, our goal here is to alleviate the complex drawings that we're starting to see that take training in order to be able to visualize these things, or essentially build these things in our minds before we're able to manufacture them. So we're using the 3D CAD software. So another cool metric about MBD is if we were to look and see how much time is spent per week creating drawings, we'll see that's a pretty exorbitant amount of time, right? So as engineers, as designers, we spend a lot of time in SOLIDWORKS, we think. But if we tracked the amount of time that we're doing that, how much of that time is actually spent building models? And I think if you were to ask yourself that question, you'd see probably not as much as could be, right? We spend a lot of times actually generating drawings, or in a lot of cases, I know tons of engineers, we spend a lot of time actually out on the shop floor kind of explaining the drawings to different people, right? So different welders, to different machinists, to different assemblers, so that they know exactly what your intention was, what the goal was behind the design. And then after that, there's a bit more documentation that needs to be done. We realized that we could probably clarify this information out by just writing an additional operating procedure, how to attach this, what the bolt torque needs to be, so forth, so on. But then when we get to the machinists, we see that they're generating documentation as well. They're taking the drawing that you provided to them, and they're essentially drawing over it in red lines and saying, okay, well, this dimension's great. We're going to use this tool, or we're going to add this amount of tolerance to it so we can actually build this, or we're going to walk through this process, whatever their goals are too. So you can see that they're adding on to this process. And so the goal behind MBD is that we start to alleviate some of these hours by giving them an intermediate platform, that 3D CAD software that has all the relevant data behind it. And that doesn't require users to actually have the CAD system inside of it, or the CAD system to interpret the data. That no longer requires the extensive knowledge with 2D drawings to be able to build this thing inside their minds so that they can actually manufacture this. So in essence, we're going to go, or the goal is to move from a very complicated 2D drawing like what we see here on the left side, to a model that has all of the relevant details in it, and we're still capturing those views, but we'll see them in a little bit different, easier to understand way. So if we take a drawing like this, and we look at this drawing, we can see that there's 18 views on this drawing. And with these 18 views, there's 14 detailed views, right? So there's a lot of detail in this model, a lot of things that are critical in nature that we want to make sure that they get built correctly. And if we look, there's 11 instances where we talk about datum feature A. The goal here will be to take this drawing and get all the same information out of it by simply using a CAD model and inside the CAD model, just basically being able to toggle the relevant information on or off depending on the view or depending on the needs of the user. So in this case, we'll take all of that same information and give that to them in a 3D environment where they can rotate it, they can look at dimensions, see surfaces, and they're no longer required to try and interpret a 2D drawing. So we'll do this in just a couple of minutes. We're gonna jump into the software and actually show you how this is done. But real quick before we finish up, essentially what we're talking about in the manufacturing process, right, is we're gonna step through our normal process using ABC, whatever our design process is. And currently we generate 2D drawings before we actually export this information out to our machinists. And what's interesting to note is this is actually done from a study from the Office of the U.S. Secretary of Defense, is all of this costs money, right? Every aspect of this costs money. And if we were to account for all of that money, almost a third of all the engineering dollars were spent generating 2D drawings. Yet, when we're all said and done and we're looking at the final XYZ steps, up to 60% of those drawings don't actually match the 3D CAD model. Now you could say that's pretty difficult to imagine, right? Because we all know how SOLIDWORKS functions and how it works, that you build a reference inside of SOLIDWORKS and the drawing is based off of that. But there's pretty easy ways to fudge that information or to export it out to PDFs and overwrite it. All kinds of different ways to tackle kind of getting the idea across without having to go through and change the 3D CAD model. But this is just based off of kind of what they have going on there. So another way of thinking about this is we've all dealt with drawings before. I'd be curious to know how much money your organization spend on things like printer ink or paper. One company was also interested in this, so they looked at it in a different way. They did a scale, essentially. And so what they did is they looked at one of their systems, one thing that they do build. So in this case, a ground combat vehicle. And what they compared it to is the weight of the ground combat vehicle versus the weight of all of the paper that's used to define this model or this machine. So you're looking at things like the part drawings, the assembly drawings, specifications, bills of materials, QA provisions, so forth, so on, inspection reports, maintenance guides, product manuals, everything there. And if you weighed all of that information, put them side by side, which one would be heavier, the tank or all of the paperwork? And I'd be curious to see how many of you guys thought the tank was heavier or how many of you guys thought the paper was heavier. But if we were to go based off of strictly what they've told us, they said, you know what? Unsurprisingly, it's the paper. The paper is actually heavier. And this actually isn't the first time we've heard from an organization that this is true. So I'm not sure how many of you might be familiar with an organization known as Textron, right? Textron, popularly known for the Cessna aircraft. They also quoted that every time they ship a product, they have to ship a truckload of paperwork. We hate to do it, and we don't want to do it anymore. It's a direct quote from somebody at Textron. So pretty cool. So what is MBD? What are we going to be doing today? Essentially, what we're going to try to do, or what we're going to try to get across, is taking the 3D CAD model and then still getting out all of the relevant stuff that you've done in the past as far as your inspections, doing the reporting, walking through your CMMs and your machining processes, and instead doing all of this stuff in a 3D CAD environment or using a 3D CAD environment to help generate this information or populate this information. And if we were to evaluate this from a production standpoint or a productivity standpoint, there was a study done, not sponsored by SOLIDWORKS. There was a study done based off of drawing-based manufacturing versus model-based manufacturing. And so when you look at a fully annotated model and a fully annotated drawing, it was taking on average about 83 to 85 hours per build out for one of these components to be done. Versus if we had done the same thing using model-based definition, full annotation, we alleviate all of the questions that have to go back and forth between the manufacturer and the users or the designers. And we were able to stream that or slim that time down to less than 20 hours to complete a full build out and understand how to do the part. If we were to look at another case where we did hybrid annotations, we were able to move from about a 60-hour work period down to about an 18-hour work period. So not as significant a savings, but still pretty different, pretty drastically different. And then the same thing in the reduced annotation, where we went from about 40 hours down to about the same thing, 15 to 16 hours to generate it. So not much time savings over the hybrid annotation for the model-based definition, but still a pretty significantly less amount of time needed to build, understand, and start the manufacturing process on these parts. So why are we talking about MBD? Why has MBD suddenly come to the front of everybody's attention? So about 5 years ago, I think it was now, military standard A31000A, or sorry, military standard 31000A was released. I think it was about 2013 or so, in which the Department of Defense actually outlined exactly what they like to see when they're having 3D CAD models with all the information on it. They've actually started to, in some cases, different contracts will actually see this pop up on them as a requirement. So not as a broad spectrum requirement, but you might see these in some cases. And what's starting to happen is that we're starting to get a trickle-down effect, right? So you have organizations like the Department of Defense that is calling these out as part of their primary contracts, and they're giving it out to their different companies like Raytheon. And Raytheon then has these now new constraints that they have to follow. So what are they going to do? They're going to pass these down to their suppliers. Well, and then these suppliers are going to pass these down to their suppliers. And we're going to start to see this waterfall effect, right? So it's going to start moving down from the Department of Defense to all aspects of the businesses. And eventually what we'll actually see is a build-up effect as well. So these small businesses are now going to start tackling based off of these workloads, and they'll see the efficiency there. And you'll start to see this start to branch into other organizations where it starts at the ground and builds itself up instead of at the top of the tree. So that's the idea behind MBD currently. So we're looking at large enterprises and organizations that have adopted it currently, and they're passing it down to their suppliers and their contractors and downstream all the way. And eventually we'll start to see it move upstream in other organizations. And again, the idea behind this is that we're going to take the 3D CAD model, the thing that we use to generate things like simulation and visualize our photo renders, and we're going to start to create the models, the model information inside of it, the tolerance values, the dimensions. And we're going to put those in 3D PDFs that are easily readable by all users and start to pass that information along into other systems so we can do things like stack-up analysis, 3D printing, machining, and finally just inspection. So we can get a lot of information out of details like this. And eventually what we'll see is that this is kind of where we'll start to take over. I apologize, guys. There we go. It'll start to take over. So the 3D CAD model is going to be the center of all things. So simulation, rendering, CAM, stack up, so forth, so on. And hopefully we'll start to break that knot with our 2D drawings. So let's go ahead and jump over to SolidWorks here, and let me show you guys a little bit about what this actually looks like. What does this this software, this magic that we've been talking about for the last 20 minutes actually equate to? So we'll go ahead and jump into SolidWorks. And I do see there's a couple questions. I'll go ahead and answer those questions here in just a little bit if that's okay. I don't want to lose too much train of thought. But we'll jump into a 3D CAD model, and we'll discuss a little bit about how this stuff is done. So we all know that you can take a 3D CAD model, right, and you can build it inside of SolidWorks. But how many of us are familiar with the ability of adding dimensions, these outside dimensions, onto the system that can then be tolerance, that we can add tolerance values to? So this is actually something that's been inside of SolidWorks for quite a while. It's been known as Dim Expert. So there's a tab inside of all SolidWorks users. You have the ability of enabling this or disabling this. And a couple of years ago, SolidWorks actually introduced a new button called Dynamic Annotation View. And what this does is it allows you to fully dim expert your model, placing all the elements in different orientations, the relevant fields. And by turning this on, you're now able to slowly rotate the model. And as you come into a view that might have these dimensions, these critical dimensions actually located on them, they'll start to become apparent. So they're not overriding all of your user experience, right? So you're not just seeing a spider web of all the dimensions there. Now you can still overdo this. You can still put too much information there, but the idea here is that it's simplifying the software for you, or it's simplifying the idealization process. So as I look at it from my right view, I can see just the relevant dimensions. As I look at it from like a front view, if there's any relevant dimensions, I'll see them. Back view, so forth, so on. And what the goal will be is with model-based definition, we'll still create drawing views like we did in our 2D drawing, but instead we'll do it in a 3D realm. So instead, you'll see at the bottom when we have a 3D view tab, we'll use dimExpert to place these dimensions. We'll use dimExpert to apply things like tolerance values if there is a tolerance value that needs to be done. So bilateral tolerance value, we'll go ahead and just add a tolerance value to this component here. We can still add those tolerance values, but then we're going to capture these views in different orientations, different model locations, and see the same information we would want on a drawing, but in the 3D model. So to save and store this graphical information so that it can still be rotated, we can look at it, see exactly how it's behaving, see different orientations of the model with all the critical dimensions. But then we'll actually export this information using the SOLIDWORKS MBD utility, adding notes to our fields and our callouts and so forth and so on, but generating what's called a 3D PDF. So this 3D PDF is just a PDF then that can be used to view the output. So we'll take in, we have our nice title block in here. But then once we've loaded the 3D PDF, we'll actually be able to select these models and evaluate them inside of our PDF viewer. So all users will now have access to this, and you'll see that they can rotate it and they can click on it and try and figure out, okay, what is this dimension? It's measuring from here to here. It's easier to understand. It doesn't take as much time or effort to figure out exactly how this thing might be built. So as we start to transition, we can see, okay, view 1, view 2, get a little bit easier to understand. Maybe those dimensions were stacked up on top of each other. It didn't always make the most amount of sense. I no longer need to communicate to an engineer like, hey, I don't understand what you're talking about. I can now look at the exact dimension as it was placed and see what's going on here. And we'll step through just a couple more examples here, essentially just storing all the information. And then it's even gone so far as to store all the graphical information for when we created that section view, right? So I have the section view now present. And you can see that there's actually toggles as we jump back and forth between more and more views inside the system. So the idea behind this is that we've taken a lot of the 2D drawing element out of this, and instead we're fully detailing the models in our 3D CAD environment using our softwares like dimExpert, our datum patterns, our geometric tolerance values. And we're capturing those views just by orienting it correctly inside the software, saying, you know what, I want to view it from this angle. And we're going to go ahead and capture this 3D view. It gets placed, and I just name it and say, you know what, I want to include annotations on the front plane, the right plane, and in my notes area. We can create more annotation views as needed as well, but then we'll call this back view. And then once I'm done, I'm happy, everything's working. I then have the ability to publish that 3D PDF and include all of these views. So that overview, that side, section, section side, and the back view that we just generated, just by simply selecting them out of the list and saying, you know what, the ones that I want to make sure are in this 3D PDF, they just happen to be these ones. Oh yeah, I also want an isometric view and a front view. And then we have templates that are pre-built or that you've fully customized for your organization that you're exporting this stuff to. Now what's also cool is part of the standard is that you do include a CAD neutral file. So in this case it's a step file, and that step file actually has the same information embedded inside of it. So if you open up that CAD file on a system that can read it, you'll actually be able to see all of these dimensions that are placed side by side with your step files or your STLs. And I think in this case it's a step 242 file. So at the bottom you'll see there's the ability to create and attach a step 242 file. And what that'll do is just inside of our PDF, you actually see that there's a step file that gets embedded inside the PDF document that can be downloaded. So simply by having the PDF, I also have the CAD file that's necessary to manufacture this if we want to use CAD-centric manufacturing processes. So we can download this thing and then open this inside of whatever CAD system we need in order to walk through the build process. So I'll show you one more quick example just so you can see kind of what the potential output looks like on this. But in this case, we have another 3D CAD model fully done up. We'll access the 3D PDF and we can see all of that same detail, right? So we see the part. If we looked at a view like this, it might be confusing in a 2D drawing, but again, we have the ability of rotating this and see, okay, what does this thing actually mean? All right, now you can see now what's happening. I'll go ahead and jump back to the view. And I can start to understand exactly what's going on without the need of consulting another engineer or even another coworker to say, hey, this drawing makes no sense. And jump to the right detail view, see the relevant information. Same thing here. And finally on the flat side. So as the part gets completely flattened out, we can see how it's going to be cut out in the process. So there are a couple questions coming through, and I'll go ahead and take a couple minutes here to answer some of those. One question came through, what about parts and assemblies? So the software does work for assemblies, and I believe I have one here. Let me grab one real quick for you just to show you. So this is an assembly that I'm opening up. And so depending on how you build this assembly, you could actually include things like bills of materials inside of this one. And my viewport might just be slightly off. But then I have a full bills of materials that's going to highlight and show me different components as I select on them. So as I start to dig through the system, you'll see things will shade or unshade. So there is ability to do full assemblies as well. So you can bring this in parts list and in assemblies, getting bombs. Another question came through. Can geometric tolerances be automatically passed through to the CAM process so it won't need to be manually entered and interpreted into the CAM system? So that's a good question, and some of it is dependent upon the CAM solution that you're using. So for SOLIDWORKS CAM, we can use the dim expert function. So any dim expert that you use and you place the tolerance values in there, and don't quote me on this because unfortunately I'm not a CAM, a big CAM user, but I believe that the CAM is able to decipher that information and do the tolerance-based machining so that it can automatically interpret it. But I'm not sure if that includes geometric tolerance values. Let me check for you real quick here. So I'll just go ahead and turn on that new SOLIDWORKS CAM that's available with all 2018 subscription users. And once that's done loading here in just a second. There we go. There is a tolerance-based machining here. Let me see what the settings say, if there's anything for geometric tolerances. I haven't dug into this one too much yet. So it looks like it's just looking at the tolerance condition. So 5 decimal points, 2 decimal points, 1 decimal point, 0 decimal points. I don't know, honestly. I'd have to dig into that question for you and find out if it can deal with the geometric tolerance values or not. And then another question came through. In a 2D drawing border, there's an alphanumeric coordinate system for drawing sub areas, allowing for unambiguous communication of where a discussed subject is located on a drawing. For example, going to column C, row 7. How is the guiding of the other party to the subject feature is resolved in MBD? So in MBD, there should be less ambiguity, right? If we're looking at a specific section, it's part of the 3D model. It's not, we don't have to reference back to an original or see what the approximate location is. If we're looking at a detail view or section view, we're just taking that CAD model and actually sectioning it out. And then we can use the different aspects of that 3D model to start to dig into it a little bit more deeply. So with the detail views or the different orientations, it's actually just part of the CAD model. So it's very intuitive to be able to just look around, rotate the model a little bit to get a better picture of how this model is actually done up for us. So ideally, the communication aspect would be gone. Another question just came through. What about first article inspection data? So that's a great question. So SOLIDWORKS 2018, for most of you guys, hopefully you're aware that SOLIDWORKS Inspection is a software that has been available through SOLIDWORKS for quite a while now. But in, I believe it was 2018, might have been 2017, we can now actually do inspections on full 3D CAD models. So if we have all the different drawing views, all the different views inside of here, SOLIDWORKS Inspection now works using all the 3D content. So as I go ahead and just kind of click through here, I'm just going to go ahead and skip to the end where it actually starts to grab dimensions for us. You'll see that it jumped through all of those views very rapidly for us, threw a bunch of balloons on those, and grabbed all of the inspection critical information, or whatever my default settings were for it. I didn't really spend any time doing it right now, but it grabbed all of that information, and then inside the inspection tab we can export the 3D PDF, which will have all of these different views. These views all have the ballooned values on them, right? 1, 2, 3, 4, 5, 6. All of the different dimensions that we've had it call out, and we'll export the 3D PDF just like the other 3D PDFs we saw, but we'll have the balloons now present. And then we can also export to Excel, so that for the QA guys, Excel will then have the report for this. So if I just use the standard AS9102 form, we'll go ahead and now just export it. It'll generate the Excel document that has the required values on it, and starts to pre-populate the information for us based off of whatever my default templates were. So we can see that it's starting to fill out certain aspects of it. So we're just trying to make, well, SOLIDWORKS is essentially the dream for SOLIDWORKS right now, right? Is to take the CAD model and make it the center of all the environment. All right, so another question just came in. Is MBD an included module? So MBD is not an included module. So Dim Expert is available for all SOLIDWORKS users. You do have the ability of creating these dimensions, and the dynamic annotations view will be present for you, but without a license of MBD, you won't have this 3D views tab on the bottom. So you'll be able to populate your drawings or populate your models with all the Dim Expert dimensions. And you can do a hybrid approach where you then take this information, once you place all the Dim Expert values, and you can create a drawing off of this. There's actually an import to grab all the Dim Expert drawing dimensions. So you can see under the import annotations here, one of the options is Dim Expert annotations. So that way, as I grab a view and drop it in, if there's a Dim Expert value that's attached to it, it'll associate those Dim Expert values in the drawing for you as well. So it can be a way of speeding up the drawing process without necessarily going the full MBD route. More of a hybrid approach to this, where we're still detailing the model, but then building a 3D or building a 2D drawing based off of that. But yes, it is a separate module if you wanted the full MBD functionality to capture the views and then export as a 3D PDF. All right, so I think I answered everybody's questions. If you have other questions, please feel free to toss those into the questions dialog box in the GoToWebinar interface. Otherwise, I think that's most of the content I had to cover for you guys today. If you have questions, feel free to reach back out to us here at Decide Solutions. Otherwise, stick around here, ask your questions. I'm happy to kind of continue helping you guys out with the MBD aspect of this. Otherwise, I do want to thank each of you for coming today. Hopefully you guys learned a lot about what SOLIDWORKS MBD was, what the whole MBE process is, and why we're starting to see it more and more prevalent in all engineering aspects. If you guys have questions, feel free to reach out to us. Otherwise, thank you guys all for coming. We hope to see you next time. Yes, this webinar is recorded, and it will be available probably like tomorrow-ish or so. It should be posted to our YouTube page. So youtube.com/Decide Solutions. So it should be published to our YouTube page in the next couple of days or so. If your company does not have access to YouTube, shoot me an email and we can get you the recording directly. Awesome. Thank you guys. Thank you for coming. All right, so I don't see any other questions rolling through. I'm going to go ahead and end the recording so I can start processing this and getting it published up to our YouTube page. If you guys have questions, feel free to shoot me an email and I'll go ahead and try and respond to those as promptly as possible. Thank you guys.